Fine. So screen is visible, right?
Yes, sir. Visible, sir.
Okay. Fine. So suppose I have, next we have done up to this metal carbon double bond. So suppose I have metal carbon triple bond. Okay. Suppose I have this kind of bond, metal carbon triple bond, and there you have hydrogen. So in this method, tell me, if I consider ionic method, how many electrons, and neutral method, how many electrons are there? So neutral method, how many electrons carbon will get?
One.
No, no, neutral method.
Three, sir.
Hmm?
Three.
3, right? See
Three.
here also, if you see the double bond, neutral means what? Homolytic cleavage, na? So homolytic cleavage means what? This carbon will get one electron, metal will get one electron. Again, this bond will break, so again one electron, one electron. So when you have triple bond, that time the three bond will break like that. So basically, three electron you will get for the carbon center. Sorry, in neutral method you will get three electron. Okay, and if I consider ionic method, that time what? You will get
Six electron.
6 electron. Okay, but keep in mind here it will be eta 1, not eta 3. Okay, because only one metal center is attaching with this ligand. Okay, or I can say the number of donor atoms is only one, that's why eta 1. Okay, so similarly, suppose you have this carbonyl group. So here you have oxygen is positively charged, carbon is negatively charged. So basically this carbon is donating electrons to the metal center. Okay, so CO is what? CO is basically a neutral ligand. So I told you, if you consider one neutral ligand, so that time the electron donation will be what? 2 electron for neutral method, and for ionic method also the electron donation will be 2 electron. Okay, and the formal charge will be 0 here because it's a neutral ligand. Okay, clear? Clear? This thing clear? Here also it is what? Here also it is eta 1. Okay, here also it is eta 1. So basically this pi bond are two electron donor and these are neutral ligand. Okay, now uh, suppose I have this metal, then I have here C double bond O, and here you have alkyl group. So metal, C double bond O, alkyl group. So if I consider neutral method or ionic method, tell me how many electrons will be there for neutral method or ionic method? So neutral method means what? Neutral method means homolytic cleavage. So if you
One.
do homolytic cleavage, yeah, neutral method you will get one electron, and if you do ionic method, that time you will get two electron. Okay, ionic method means what? Ionic method means this bond will fully break. Okay, when the bond fully breaks, it is getting negative charge and metal is getting positive charge, so you will get two electron. Okay, and what about the formal charge? Formal charge will be
Isn't the
minus 1. Yeah.
if the negative charge moves on to carbon, is that not stable? Isn't that unstable?
Basically, it's not that kind carbo. It is not carbocation, right? It is your carbanion.
Yeah, so it becomes unstable, no? Shouldn't it go the other way?
Other way, if you do that time, you will get carbocation. That is way more unstable, na? Suppose CO means what? Carbon oxygen double bond O means what? This is sp2 hybridized, na? So
Yeah,
sp2
but still,
hybridized. If you
carbon
if
is
you have negative charge,
electrophilic.
so this is electronegative, na? So if you have negative charge on some electronegative species, that is much more stable than if you have positive charge on some electronegative species. Okay,
Okay.
suppose I am writing A minus or A plus, which one is more stable? Definitely A minus, na? So it is electronegative. So if you have negative charge on some electronegative atom, so that will be more stable than corresponding carbocation. Okay.
Okay.
Okay, clear, fine. Okay. If you break in the other way, you will get positive charge. That is way more unstable. Okay, fine. Suppose you have this example. Okay. So now tell me, in neutral method, how many electrons are there? Ionic method, how many electrons are there?
3 and 4.
So neutral method, you will get 3 electron, right? So neutral method, you will get 3 electron. Okay, fine. And if I talk about ionic, so see now how the bond
Sir,
will be.
and two, sir.
Ionic will be 2. Okay, ionic will be 2 because you have to break the bond like this. Again, it is aromatic system, na? If you break it like this, what you will get? You will get this positive charge. That is more stable because you are getting aromatic. So it will be 2 electron, not 4. Okay. So this kind of system, be careful, huh? These are simple example, but in exam we do mistake here also. Okay. So you have to be careful. Only just check what you are getting, aromatic system you are getting, or you are getting anti-aromatic system. Those things you have to check. And what about the formal charge? Formal charge will be what? Definitely positive charge is there, so that means what? Plus 1. Okay, formal charge will be plus 1. Clear? Now if I draw this molecule, this, that time in neutral method you will have how many electrons? 1 electron. And ionic method you will have 2 electron, and formal charge will be -1 because here the bond will break like this. Metal will get positive charge here, but here the metal will get negative charge. Okay, so whenever you are getting aromatic stability, metal will get negative charge, but if no aromatic stability is there, that time normally metal will get positive charge. Clear? Clear? Done?
Yes, sir.
Done? Okay. So this compound you have, and now this pi bond is donating electrons to the metal center. Okay, so first of all tell me, in neutral method how many electrons, ionic method how many electrons? So this kind of double bond or triple bond is what? Pi bond is what? Neutron, na? Pi bond is
So
what?
0,
No, pi
0
bond is
and
why 0 electron? It is donating electron, na, to the metal center.
Sir, neutral is 2, ionic is 4, sir.
Ionic is 4. How ionic is 4? Okay, see.
both will be same, 2, 2.
Both will be same. Where I have
Yes, sir.
written? I have written somewhere, na, in the starting previous class. See, if you have neutral ligand, then the contribution same in both the methods. Okay, so if you have pi bond, this pi bond, double bond are basically what? Neutral ligand. So that means in neutral method also you will have 2 electron donation. In ionic method also you will have 2 electron donation. Okay, and the formal charge will be what? Formal charge will be
0, sir.
0,
0, and eta value will be
2.
2. Good, eta value will be 2. Okay, now suppose I have this, this. Now this double bond is also donating electrons, this double bond is also donating electrons. So now tell me, in neutral method how many electrons you have, ionic method how many electrons you have?
4.
So neutral method you have 4 electron, ionic method also you have 4 electron. Formal charge will be what? Formal charge will be 0 and eta value will be, what will be the eta
4.
value? Eta value will be 4, because here all the 4 centers are attached with your metal center. Okay, fine. Now suppose I have this, okay. So now tell me, neutral method, ionic method.
1, 2.
Neutral method will be 1 electron, and here ionic method you have to break like this, because if you break the bond like this, so what you are getting?
Aromatic compound.
Aromatic compound, 4n plus 2 number of pi electron. Okay, 4n plus 2 number of pi electron, 6 pi electron you are getting. So basically ionic you will get 2 electron, neutral method you will get 1 electron. That's it. And formal charge, what about formal charge? You are getting negative,
-1, sir.
-1. Formal charge will be -1 and eta value will be 1. Clear?
Yes, sir.
Clear, right? Okay. This bond, here also I have metal, and this double bond is also donating electrons to the metal center. So now tell me, neutral method how many electrons, ionic method how many electrons, and formal charge, tell me. So neutral method how many electrons you will get?
3, 4, -1.
Yeah, neutral method you will get 3 electron, ionic method you will get, again it will be aromatic system. If you break like this, it will be aromatic system. So 4 electron in 2 electron from this double bond and 2 electron from this negative charge. So 4 electron in ionic method, and formal charge will be what? Formal charge will be -1. And next is eta value. Eta value will be what?
3, sir.
3, because here double bond, so that means these two bonds and here one bond, so eta 3. Eta 3. Okay, good. Another is that, suppose you have this, and here you have metal center. Okay, now this is also donating electrons, this is also donating electrons. So now tell me, neutral method how many electrons, ionic method how many electrons, formal charge how many electrons? Sorry, formal charge will be what? Yeah, neutral method how many electrons are there? So 2 electrons you are getting from this double bond, 2 electrons you are getting from this double bond, and here it will be homolytic cleavage, so total you will get 5 electron. If you do ionic method heterolytic cleavage, so that time you will get 6 electron. Formal charge will be -1, and eta value will be what?
5, sir.
5, right? So this kind of thing, na, in exam basically they will not show you like this, they will write down like this. Okay, in question paper they will write down like this, like your resonance. Okay, and then they will draw from the inner side. So if they are drawing like this, so that means all the double bonds and this carbon also, all the carbon atoms, whatever how many atoms you have, 1 2 3 4 5, so all the atoms are involving, or all the atoms is actually donating electrons to the metal center. Clear? Suppose this system also I can draw like this also. They will not show you like this. So this double bond is not donating, so that they will write down like this. So how many, what is the value? Eta 3, right? So that means 1 2 3. So they will show you like this, like this. Okay, so if they are showing like this, so that means 1 2 3, these three atoms are donating electrons to the metal center. If they are drawing a circle like benzene ring, so that means all the carbon atoms are actually involving, all the carbon atoms are donating electrons to the metal center. Is it clear? Is it clear?
Yes, sir.
So this kind of ligands are actually known as your fluxional ligands. Okay, sorry, uh, fluxional ligands. So fluxional ligands means what? So write down that can change hepticity. So number of donor atoms they can change hepticity. Hepticity value they can change. Okay, but the formal charge will be same. Okay, this formal charge will remain same, that will not change. Okay, hapticity value they are changing, but formal charge they will not change, formal charge will remain same. Okay, so these are the basically types of your fluxional ligands. Fluxional ligands means what? They are changing the hapticity value, but formal charge will remain fixed, that will not change. Done. Done.
Done, sir.
Done. Okay, so suppose I have this system 1 2 3 4 5. So metal is attaching with here, here you have double bond, here also you have double bond. Now suppose you have 1 2 3 4 5. So here also you have double bond, here also you have double bond. Okay, now suppose this double bond is donating electrons to the metal center, and another molecule is like this 1 2 3 4 5. So here you have metal center, here you have double bond, here you have double bond. So this double bond is donating electrons to the metal center, this double bond is also donating electrons to the metal center. So now tell me, first of all, number of electrons in neutral method, ionic method, then formal charge value, and then eta value. Tell me one by one.
1 2 minus 1.
Here neutral method you are getting how many electrons? 1
1
electron. Ionic method you will get 2 electron. Formal charge will be minus
minus
1
1.
and eta value is 1. Okay, now I am coming to next. Here neutral method, how many electrons?
3
So 2 electrons from this pi bond and 1 electron from this bond, so 3 electron. When the bond will break, so what you will get? 4 electron. Okay, formal charge will be what?
minus
Minus
1.
1. Eta value will be
3
3. Here neutral method
5
5 electron, ionic method
6
6 electron, formal charge
minus 1.
minus 1, eta value will be
5.
right. So this is basically example of your fluxional ligands. You can see the formal charge is not changing, formal charge is remaining same, it is in constant minus 1 value. But if you see the neutral method and ionic method, sorry, hapticity value they are changing, eta 1 to eta 3 to eta 5. So that much variety you are getting. Okay, clear? Clear?
Yes, sir.
Clear. Smita is there. Smita, clear?
Yes, sir. Clear, sir.
Clear, right? Okay. Ask me if you have any doubt, huh? Anything you are not getting, just ask me.
Okay, sir.
So suppose I have this
Okay, sir.
benzene ring. Suppose I have this benzene ring, and now a metal is directly attached with the benzene ring. Okay. So metal is directly attaching with the benzene ring. So that time what will happen? Now see. Again you can think like that, sir, we will break like this. Okay. So two possibilities there. If you break like this, what you will get? You will get negative charge on this sp2 hybridized carbon, and metal will be positively charged. And another possibility is what? It can break like this also. So that time the benzene ring will become positively charged and metal will be negatively charged. So which one is stable? More stable?
First one.
First one. So as I told, if you have sp2 or sp hybridized carbon atom, they are electronegative in nature, right? So they will always occupy negative charge, not positive charge. So this one is stable. Okay, this one is unstable. So if you have benzene ring, so that will not break like this. Okay, the bond will break like this. So here also in neutral method, if I break this bond in neutral method, you will get one electron. In ionic method you will get two electron, and formal charge will be what? Formal charge will be -1, and eta value is what? 1 only. Okay. Now suppose I am drawing the benzene ring like this, and then I am showing like this. So now tell me, neutral method how many electrons, ionic method how many electrons, formal charge is equal to what, and eta value is equal to what? Tell me.
6, 7.
Not 7. Why 7? Here all the pi bonds are involving, na?
6, 6, 0.
6 electron, formal charge will be 0 and eta value will be 6. Okay.
6.
Eta value will be 6. So double bond, double bond, double bond, all the three double bonds are now donating electrons to the metal center. That's why I am writing it within the circle. Okay. So here neutral will be 6 also, ionic will be 6 also, formal charge is 0 and eta value is in 6. Okay. This thing you can show like this, na? See, not 7 electrons. Check. So this double bond is donating, this double bond is donating, as well as this double bond is donating. So this thing we are not drawing like this, we are drawing like this. Simply we are drawing like this. Clear? Clear, right? Okay, fine. Now let's move to the next example. Suppose you have this kind of system. Okay, so here one double bond, here. So this is donating electrons to the metal center. This double bond is also donating electrons to the metal center. So neutral method how many electrons, ionic method how many electrons, okay, eta value and formal charge value. Tell me. So in neutral method how many electrons are there?
4, 4.
4 electron. Ionic
Also.
4. Eta value,
Also.
okay, sorry, eta value will be, yeah, eta value is 4. Okay, and formal charge
0.
0. Fine. Okay, now suppose you have this 1 2 3 4 5 6 7. So here I have double bond, here I have double bond, here I have double bond, and this is attaching with the metal center. Okay, so neutral method how many electrons, Ionic method, how many electrons? Formal charge and eta. So neutral method, how many electrons are there? Neutral method, how many electrons?
Neutral method is 1.
One
One, sir.
electron. Ionic method?
2.
0, sir.
0, 0.
0 na. Don't do mistake.
Yes.
Here this bond will break like this na. Aromatic system you will get. If I break like this, so what I will get? 1, 2, 3, and you are getting a positive charge. So now it becomes 1, 2, 3, 6 pi electron. That means aromatic system, right? If you break the bond like this, that time you will get negative charge here. It will become anti-aromatic system. So basically I am getting ionic method, I am getting 0 electron. Formal charge will be what? +1, and eta value will be 1. Okay, because with only one carbon center the metal is attaching. Fine. Okay, suppose I have next this 1 2 3 4 5 6 7, this you have metal center here. This double bond is donating electrons, this double bond is donating electrons, this double bond is also donating electrons. So neutral method, how many electrons? Ionic method, how many electrons? Formal charge and eta value. So how many electrons in neutral method? So this double bond donates 2 electrons, here 2 electrons, here 2 electrons, 6 electron on homolytic cleavage, so that means 7 electron, right? If I talk about ionic method, so this double bond will break like this.
No, sir.
This double bond will break like this. So ionic method you will get 6
6.
electron. Formal charge you will get +1, and eta value, here the eta value will be 7. All the 7 carbon atoms are attaching with the metal center. Done? Understood? Okay.
Yes, sir.
Okay, fine. Okay, now suppose you have this 1 2 3 4 5 6 7. Okay, so here I have double bond, here I have double bond, here I have double bond. Okay, now this double bond is donating electrons to this metal center, this double bond is donating electrons, this double bond is also donating electrons, right? And here you have 2 hydrogen. So now tell me electron contribution by neutral method, ionic method, formal charge and eta value.
6, 6, 0, and eta 6, sir.
6 electron neutral method, ionic method also you will get 6 electron, formal charge will be 0, and eta value will be what? 6. Okay, now if I write down this 1 2 3 4 5 6 7 8, so suppose I have this 1 2 3 4, this double bond is donating electrons to the metal center. So ionic method, how many electrons? 2 electrons. Neutral method also 2 electrons. Okay, eta value will be 2 and formal charge will be 0. Clear? Clear? Now suppose you have this in this example, tell me number of electrons in neutral method, ionic method, formal charge and eta value. Tell me.
4, 4, 0, 4.
Neutral method is 4. Okay, ionic How many?
Oh, sir.
4. Formal charge will be 0. Eta value will be 4.
So,
Right. Good. Suppose you have this 1, 2, 3, 4, 5, 6, 7, 8. Right. So this. Now neutral method how many electrons? Ionic method how many electrons? Formal charge is equal to what? And eta value.
8, sir.
Neutral method
8808.
8808. Good. Clear? So I think now it's clear, right? How to check the number of electrons in neutral method, in ionic method, what will be the formal charge and what will be the eta value. Okay, fine, very good. Now suppose you have this kind of thing. So now tell me, in neutral method how many electrons, ionic method how many electrons, formal charge and eta value.
6606.
So neutral method is 6, ionic method is 6, formal charge is 0, eta value is also 6. Very good. Okay, now suppose you have this kind of molecule. Here tell me. Tell me neutral method how many electrons, ionic method how many electrons?
2202.
2 2. No, no. This metal is getting electrons from the two double bonds, na? Hmm.
4, sir.
So here don't consider like this, that 2 4 6. If you write down here like this, that neutral method 6 electrons, ionic method 6 electrons, that will be wrong. Don't do like that. Okay, so keep in mind one thing here, that this hapticity na, this hapticity is a continuous process. Hapticity is a continuous process. Okay, so if you have continuity of double bond, so that means delocalization is present there, then only you can call eta 6, otherwise you can call. So now I have to actually check separately. So this thing I have to check separate and this thing I have to check separate. So here neutral method I have 4 electrons, ionic method also I have 4 electrons, eta value will be 4 and formal charge will be 0. For this right hand part, neutral method I have 2 electrons, ionic method I have also 2 electrons, formal charge will be 0 and the eta value will be 2. So like that you have to do separately. If you are writing neutral value 6, ionic method 6 electron, eta value is 6, so that will be wrong. So keep in mind, hapticity is a continuous process. If these double bonds are in conjugation, then only it will take place, otherwise not. Okay, clear?
Yes, sir.
So suppose I have this. Okay, so here I have double bond, here I have double bond, here I have double bond. Now suppose this double bond is also donating, this double bond is also donating, as well as this double bond is also donating. So that time you can write down, see, these double bonds are in conjugation, right? So that time I can write down that neutral method 6 electrons, ionic method 6 electrons, formal charge will be 0 and eta value will be 6. Okay, done.
Yes, sir.
Done, right? Suppose you have a system like this. Phosphorus is there. You have two methyl groups here, as well as you have two methyl groups here. So phosphorus has lone pair, Now it is donating electrons to the metal center. This phosphorus is also donating electrons to the metal center. So now tell me, neutral method how many electrons, ionic method how many electrons? So again, for this system, don't write down neutral method you have 4 electrons, ionic method you have 4 electrons, because see here what is the difference when I am considering this kind of system. What is the thing there? Here you have a center which is basically what, which is sp3 hybridized. Okay, this center, this carbon is what, sp3 hybridized. So you can see here also that sp3 hybridized carbon is present there. So if you have sp3 hybridized carbon present within this double bond system or within this lone pair of kind of system, so that means conjugation is not there. Okay, that means this hapticity is a continuous process, right? So this continuity is breaking if you have sp3 hybridized carbon center. So that time you have to check separately. So for this phosphorus center we will check separately. Okay, for this phosphorus center we will check separately. Okay, and for this phosphorus center we will check separately. So definitely it will be 2 electron, here also 2 electron. Formal charge will be what, formal charge will be 0. Okay, and for this one also, for the below one also, you can write down neutral method it is donating 2 electrons, ionic method also it is donating 2 electrons, and formal charge will be 0 as well. Okay, here don't so here it is belongs to what, eta 2, this thing. Okay, sorry, not eta 2, sorry. Here it will be what, it is donating to here, so this one will be eta 1 and this one will be also eta 1, because it is attaching to one phosphorus center and it is also attaching to one phosphorus center. We will write down eta 2 when it is present in conjugation, but if there is no conjugation, some sp3 hybridized center is present, that time we have to check like this, separately. Is it clear?
Why two electron in neutral method, sir?
Huh?
Why two electron in neutral method?
Because
It is
lone pair na,
identical.
lone pair means this phosphine, this is kind of phosphine na, this is a neutral ligand, this thing, neutral ligand. So if you have neutral ligand, contribution will be same in both the methods. Okay, contribution will be same in both the methods. Okay, just a minute, just a minute. हेलो, हाँ आ रहा हूँ।
अच्छा मैं जिम जा रहा हूँ।
हाँ रुको, थोड़ा आ रहा हूँ।
अरे फिर मैं यहीं रुक जाऊँ क्या?
हाँ ठीक है, तुम जिम जाओ, मैं आता हूँ।
तुम अभी निकले हो या निकलने वाले?
हाँ निकलने वाला हूँ।
मैं लैब से निकला।
ठीक है, फिर रूम आओ, फिर मैं आता हूँ।
अरे जिम कब जाओगे?
अच्छा ठीक है, तुम जिम जाओ, आता हूँ।
हाँ?
जिम जाओ, आता हूँ मैं।
एक कुछ कहो जल्दी।
हाँ जिम जाओ, आता हूँ मैं।
आ जाना।
हम्म।
मेरे भूख भी लगा बहुत जोर से।
हाँ ठीक है, आता हूँ, जल्दी आता हूँ।
ठीक है।
हम्म।
लेकिन तुम फिर करोगे ना जिम?
हाँ
तुम भी तो जिम करोगे फिर?
हाँ, आता हूँ जल्दी।
ठीक है, आ जाओ।
हम्म। Okay, fine. Okay, so what I am saying, if you have neutral ligand na, so that time contribution in both the methods will be same. Okay, suppose you have any lone pair containing molecule, so that time these 2 electrons, lone pair means what, 2 electrons. So ionic method, neutral method, both the methods it will donate 2 electrons. Clear? We have done here na, this kind of neutral ligands where we have done. See, So this phosphine, phosphorus containing ligands, these are what? These are basically your neutral ligands. So they will just donate the lone pairs. Okay. So if you see here now, this is also what? This is also your phosphorus containing ligand, na? This one is what? Phosphorus has 5 valence electrons. So out of the 5 valence electrons, 3 electrons are already making bond with these atoms, with these groups. So 2 electrons left. So that is donating. Okay.
Exactly, yes, sir.
Clear, right? Okay, if I have this, then neutral method how many electrons, ionic method how many electrons, formal charge and eta value. Tell me quickly. How many electrons it is donating by neutral method? How
Yes,
many
sir.
how many electrons?
4.
4 electron here in neutral, 4 electron also in ionic, formal charge will be 0 and eta value will be what? 4.
4.
Okay, that's it. So that is the end of our this calculation. Okay, tomorrow we will see how to find out the oxidation state, and then we will talk about bridging ligands and those things. Okay, and then we will come to 18 electron rule, those things we will come later. Fine. Any doubt from here? Any doubt?
No, sir.
No. Smita, any doubt?
No, sir.
No, right? Nayana?
No, sir.
Yes, sir. Clear, sir.
Clear, right? Okay, fine. So that's it for today. Okay, we will meet tomorrow again. Okay.
So,
Yeah.
I have a doubt.
Yeah. Tell me.
In reduction, not in this.
Ha.
Yesterday's class.
Ha.
So, trans addition in catalytic reduction of
Ha.
palladium.
Ha.
I didn't understand when exactly it is applicable. Because if, is it an exocyclic compound or it is a cyclic or only palladium? That I understood.
Okay.
But the exact circumstance of trans addition I didn't understand.
Trans addition, that means which part you are talking about? When you will get trans addition, that's it, na?
Yeah, when are we? Which starting material gives trans addition? In palladium, H2 palladium, catalytic reduction.
Which starting material will give you?
Yeah, which compound?
That can be anything, na? If you have normal, suppose, okay, just a minute. Suppose you have this example I have given, na? This example. This example, na?
Yes.
So if you have any
With
alkene
palladium is there?
if you have any alkene compound and if you are using this reagent, hydrogen in presence of palladium carbon, okay, so that time it will do trans addition. So trans addition means what? These hydrogens are adding in trans fashion. So suppose one hydrogen is coming from above the plane, so the other hydrogen is coming from below the plane. So automatically now you can fix the geometry of the methyl group, and here hydrogen is below the plane, so that means the other methyl group will be above the plane. But if you use here Adams catalyst, hydrogen PTO2, okay, hydrogen PTO2, that time you will get cis addition. So cis addition means what?
The statement. Yeah, the statement you wrote was hydrogenation of
Hydrogenation of
cyclic
substituted cyclic alkenes gives trans addition with palladium. It should be cyclic, okay, and substituted means what? Some alkyl group should be present there.
If we have a 6-membered ring and then we have a double bond that is attached outside with substitution, then what happens?
That time it's I think it's not possible, because here already we have mentioned cyclic alkenes. So cyclic alkenes means the double bond should be part of your ring, okay, the double bond should not be exo double bond.
Exo double bond will not hold.
exo double bond, that time you no need to check the geometry, no need to show the geometry. That time you can just write down
Not
like this.
not like that.
uh,
No, not that way.
so
You have it has to be directly attached to the cyclic hexane. Then
directly attached
here
means,
you have done a space, right? It's not directly attached.
so you're
Ah,
saying like this.
like that. And then you also substitute like CH3 on the other side of the double bond. Then what happened?
This kind of thing.
Yes.
uh, mm, that will not take place. Cyclic alkenes means basically the double bond should be part of your ring. Okay, that should not be exo. Okay, it should be endo.
Inside only. Okay.
Inside only.
Okay.
Okay.
Yes.
Okay.
Thank you, sir.
Okay, thank you. Apart from this, any doubt? Naina, you have any doubt from organic chemistry?
No, sir.
No, right? Okay, study well. Okay.
Yes, sir. Thank you,
Okay.
sir.
Okay, thank
Thank you,
you.
sir.
Bye.